Hey there, Charger folks, this is Mrs. Boyd. Today we're talking about similarity transformations. We want to know if the dilation from figure X to figure Y is an enlargement or a reduction first and foremost. It's an enlargement if it gets bigger. It's a reduction if it gets smaller. I know you're shocked. Those are really confusing terms. So you're going to start from X to Y. If we look at X, is X smaller or bigger than Y? X is smaller. That means from X to Y, it's an enlargement. I'm already telling you these are similar figures. We just need to know what the scale factor is from one to the other. So that's what we're looking for. I'm going to find a side that is either horizontal or vertical so that I can easily count the length. Look at X. I'm going to start here, and it's 1, 2, 3 units long. Starts at 3 on the X triangle. On Y triangle, same side is 1, 2, 3, 4, 5 units long. That means my scale factor is 3 to 5. Let's try another one. Again, these are similar triangles. We start at X and go to Y. Is X bigger or smaller than Y? X is definitely bigger. So X to Y, this is a reduction. Again, we're going to find a horizontal or a vertical line to test to see what the change of size is. X is flipped in a different direction than Y is. So I can use this line, 1, 2, 3, 4. Scale factor is the words I'm writing. But on the Y triangle, it's going to be this side, 1, 2. 4 to 2, or that's the same as 2 to 1. If you chose to use the other side, it'd be 1, 2, 3, 4, 5, 6, 2, 1, 2, 3, which is also 2 to 1. X to Y. We can't really look at those and say X and Y are definitely different sizes because you know what? They are the same size. So we're going to call that X to Y isometry. Means they're the same size anyways. So our scale factor, let's just test it out. Let's pick the top line here. We have 1, 2, 3, almost 3, and 1, 2, almost 3. So that scale factor is 3 to 3. We can reduce that though, just like a fraction, to 1 to 1. Last couple on this front page. X to Y. X is definitely smaller than Y. So we'll call this an enlargement. Our scale factor, X, we've got 1, 2, 3, 4 units. 2 on Y, 1, 2, 3, 4, 5, 6, 7, 8. So that turns into 1 to 2. Last one here, X to Y. X is way bigger than Y, so it's a reduction. Start big, go smaller, it's a reduction. Our scale factor, we need to figure out. X is 1, 2, 3, 4, 5, 6. Y is 1, 2, 3, 4. So 6 to 4, that's the same thing as 3 to 2. We always reduce these just like we would a fraction. All right, flip it on over. Hopefully your paper is working more easily than my computer is currently. So we're going to plot the given points. Let's do that first for A, B, C. We have -4, 3 for point A. B is -4, -2. And C is 1, -2. Looks like a triangle to me. You know, 3 sides in all. And then we'll plot D, which is at -2, 4. B, which is at 3, 4. And C, I think we're going to call those D, E, and F. I don't know why they're B and C. Let's call that E, though, and this guy F. That bothers me badly. And then F is at 3, -1. Another triangle. We want to know if the figures are similar by side, 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 angle, or angle, angle similarity. Well, I've got some perpendicular lines. One's vertical, one's horizontal. It's going to make it pretty easy to tell how long the sides are that way. So let's do A, B first. I've got 1, 2, 3, 4, 5. AB is 5 over BC. BC is 1, 2, 3, 4. And this is a right angle because they're perpendicular. Well, I know I've got a right angle at angle E, so let's test the sides. We'll do DE 1, 2, 3, 4, 5. And EF is 1, 2, 3, 4, 5. Again, order matters. AB, BC, DE, EF. Well, if they have proportional sides, because they're both, I drew a line wrong. Ugh. I did. I drew A, B wrong. Oh my gosh, forgive me. AB is the same. I can't even erase it. AB should be scooted this direction 1. I drew it completely wrong. So it really should be 5 and 5, not 5 and 4. You got to draw things right. Oh my gosh, I'm so sorry. They both still have right angles. So this is going to be side, angle, side similarity. They have this side that's congruent, this angle that's the same, and this side. Oh, here's hoping I can do the next 3 a little bit more accurately. Triangle ABC. A is at 0, 4. B is at -4, 4. And C is at -4, -3. Triangle. And then we'll do D, E, F. D is at 0, 1. E is at 3, 1. And F is at 0, -4. All right. Let's see if these are similar. First, I know I've got right angles here. So those are angles that are similar. AB is 1, 2, 3, 4. That's 4. ED is 1, 2, 3. So we'll put that below 4. I'll do BC 1, 2, 3, 4, 5, 6, 7 on top. And EDF will be 1, 2, 3, 4, 5 over 5. 4/3 and 7/5 are not the same. These triangles are not similar. Let's try two more. Triangle ABC. That -5, -1, -2, 4, and 1, -1. And then we've got D is at -1, -4. And E is at 2, 1. And F is at 5, -4. All right, we want to know if these are similar. There's no right angles, so I can't really easily tell what any of the angle measures are. So we're going to rely on our sides. Notice we only have two sides, one on each triangle that is horizontal. We'll have to use the distance formula to find the lengths of the other two sides of each triangle. All right, so we know AC is 1, 2, 3, 4, 5, 6. And DF is also 1, 2, 3, 4, 5, 6. All right. We can see that we need to use the distance formula. So we'll do, but let's do AB first. Distance of AB, that's the square root of the difference in the x coordinates. So -5 plus 2 squared plus the difference in the y coordinates, -1 minus 4 squared. Well, that is -5 plus 2 is -3 squared plus -1 minus 4 is -5 squared. That is 9 plus 25. That's the square root of 34. I'm going to save you some heartache. Really, what I want you to do is pause and find the distances of all these lines on your own. And now I'm going to tell you that they're all the same. They are all the square root of 34. AB and DF are the square root of 34. EF and BC all are the square root of 34. That means these are similar with side, side, side similarity. My dog agrees. Last one. We have triangle A, -5, 1, B, and C, -2, -1.5. That should be a B, I'm thinking. And then triangle DEF, -2, 4, 4, 4, and 4, -1. All right, well, we know they've got an angle in common. That's the only angle that we're able to know of, so we know this is not going to be angle-angle similarity. Okay, my stuff's not working. There we go. So we'll use our sides. We've got AB is 1, 2, 3. DE is 1, 2, 3, 4, 5, 6. Then we'll do BC is 1, 2.5. And EF is 1, 2, 3, 4. So, did I draw it wrong again? I did. It should be up 1. Oh my gosh. I am completely 1,000,000% fired. Just so you know, kids, it's late when I'm recording this. You'll have to excuse my mistakes. All right, let's try one more time. All right. So it's 1, 2, 3, 4, 5. Whew, that's what it's supposed to be. Oh, I can't erase that 4. Oh my gosh, it's a 5. We can reduce these. They're each 1/2. So we have side, angle, side, similarity. Oh my gosh, I'm so sorry for this craziness. I hope it makes some sense to you. You know where to find me if you need help.